Good morning, all of us, wherever we are watching from. Welcome. This is KUTV, and the program is Elimu Live. This is a program that seeks to address your educational issues wherever you are, both the candidates and also the other pupils. So welcome. We are going to learn science today according to the timetable, and we are going to look at the topic weather. Now you realize at the national level, when it comes to KCPE, the setting of the exam is done such that not only questions that are set come from class 8, but also come from other classes. So for that reason, we're going to look at weather, which is in the previous class. So this is to benefit both the candidates and also the others. So if you are in class 7, 6, 5, so you're not left out. So it will be beneficial to you too. So welcome once again. So we are going to look at the topic weather. So as we look at the topic weather, we first start by looking at the objectives of the lesson. So what do we intend to achieve by the end of this lesson? So objectives of our lesson. My name is Teacher Steplaton, as you can see. So we are talking about science and our topic is weather. So objectives of the lesson. Objectives are what we want to achieve by the end of this lesson. So the first objective, we are going to name some weather instruments. And objective number 2, we are going to describe how different weather instruments work. So those are our two objectives for the lesson: to name the weather instruments and also to describe how different weather instruments work. When we come to name the weather instrument, we are going to focus so much on the syllabus and what the syllabus wants us to cover. So we'll not look at all weather instruments, but we look at weather instruments that the syllabus stipulates. And if it comes to examination, that's what is going to be said in the KCPE exams. And we're also going to describe how these weather instruments work. So we first start by defining some terms. And the first term we are going to define is weather. So weather can be defined as the daily changes occurring in the atmosphere. Weather can be defined as the daily changes occurring in the atmosphere. So this is a day-to-day activity that takes place. So these changes, they are usually recorded, and that is what we refer to as weather generally. Then there is what we call the scientific study of weather. So the scientific study of weather is called meteorology. So meteorology, that is the scientific study of weather. And the person who studies that, we call that person a meteorologist. So meteorologists, these are scientists who study weather. So we can also look at another definition, that is astronomy. And astronomy can be defined as the study of stars, planets, moon, and other heavenly bodies. So astronomy can be defined as the study of stars, planets, moon, and other heavenly bodies. So the person who studies astronomy will be called an astronomist. So we have meteorology, that is the study of weather, and the person who does that is called a meteorologist. Then we have astronomy, the study of heavenly bodies, and the person who does that will be called an astronomist. Then the study of weather also is done in what you call a weather station. Just like the way learning happens in school, when we come to the study of weather, it takes place in what we call a weather station. So having looked at that, so the study of weather is done in a weather station. Having looked at that, we can now look at some of the weather instruments that we need to look at. And as I started by saying, I'll focus on the weather instruments that the syllabus needs us to cover. So the syllabus needs us to cover 4 weather instruments, and that is a rain gauge, a wind vane, a windsock, and a thermometer. So these weather instruments, they measure, or they are used to record aspects of weather or the elements of weather. So when I talk about this, I mean temperature, I mean humidity, I mean sunshine. So those are elements of weather that I'm talking about. So we can have the elements or the aspects of weather. So we have temperature, I've said temperature, we have wind, we have humidity, we have sunshine, and others. So those are the aspects of weather. And what measures these aspects of weather, we call them weather instruments. So we start with the first weather instrument, which is called a rain gauge. From the word rain, what do you think is the function, or what do you think is the importance of a rain gauge? You can answer there at home. So a rain gauge. Now from the word rain, it measures the amount of rainfall. A rain gauge measures the amount of rainfall, and the units for measuring the amount of rainfall is millimeters. So we look at a rain gauge, and it measures the amount of rainfall, and the amount of rainfall is measured in what is called millimeters. Millimeters is always calibrated as mm. Millimeters is always calibrated as mm. So a rain gauge should be placed in an open field. Now the reason for placing a rain gauge in an open field is to ensure that there is no obstruction. There should be no obstruction such that it should be able to record all the amount of rainfall that is falling. So it should be placed in an open field. When I talk about an open field, I mean a field free from tall buildings, free from trees and other obstruction. So for the purposes of recording all the amount of water that is going to be received from the rainfall. So a rain gauge, the length of a rain gauge is 45 centimeters. The length of a rain gauge is 45 centimeters. From up to down is 45 centimeters. Now these 45 centimeters, part of the 45 centimeters is put into the ground, and part of the centimeters is left above the ground. So these centimeters is not put half. It is not half 45, half 45. No. So we have 15 centimeters, which is dug inside the ground. 15 centimeters is dug inside the ground, and it is dug for two purposes, but we have the main purpose. So the main purpose why it should be dug 15 centimeters into the ground is to reduce the rate of evaporation. To reduce the rate of evaporation. Not to stop. It does not stop, but it reduces. So it is dug 15 centimeters into the ground to reduce the rate of evaporation as the main reason. So apart from reducing the rate of evaporation, it also makes the rain gauge to be firm. It also makes the rain gauge to be firm. So we have that. So it is dug 15 centimeters deep into the ground, mainly. So we take note of this word mainly. So mainly means the most important part. So it is dug 15 centimeters to reduce the rate of evaporation and also to make it firm. But remember, to reduce, that is the main point, while the other one is just an additional point. Then it is also left 30 centimeters above. Remember I said that the total length of a rain gauge is 45 centimeters, of which we have 15 that is dug inside the ground, and I've given the two reasons. Then 45 minus 15, that is 30. So it is left 30 centimeters above the ground. And the reason why it is left 30 centimeters above the ground is to prevent water from splashing into the rain gauge, such that the recordings should not include water splashed from the ground. So that is the reason why it is left 30 centimeters above the ground. Now you should be keen, because those 2 points are examinable and you're likely to be asked, which one of the following is the main reason why a rain gauge is dug 15 centimeters into the ground? So when you're given such an answer, such a question, the answer is to reduce the rate of evaporation. But in case we don't have such an answer, then the other possible answer is to make it firm. But when you have the two answers, you now go for the main answer, which is to reduce the rate of evaporation. Then you are also likely to be asked in an exam, which one of the following is a reason why a rain gauge should be left 30 centimeters above the ground? So the answer to such a question is a rain gauge is left 30 centimeters above the ground so that it can prevent water splashing into the rain gauge. And why should we prevent water splashing? We should prevent water splashing so that we can have a good recording or an accurate recording. Because if water splashes inside, then the recording is likely to be different. So it's likely to have more recording which will not be correct. A rain gauge is also made up of materials that enable it to withstand harsh weather conditions. Remember, it is usually put outside. Because it is put outside, there are so much harsh weather conditions. For example, too much sun or too much rain. So the material that is made, should be a material that it can withstand such conditions. So such a material is metal. So the casing of a rain gauge, or the outer covering of a rain gauge, is made up of a metallic material. And the main reason why it's made up of a metallic material is to withstand harsh weather conditions. And I've told you example of the harsh weather conditions that you're talking about is when there is that alternation of too much sun, you come to too much rain. So if it is made up of a material that cannot withstand, then the rain gauge is likely to be damaged. So those are points about a rain gauge. So it is used to measure the amount of rainfall. We've talked about that. So it is made up of metal, what I was just explaining, and the purpose of that is to withstand the harsh weather conditions. Then it also has a funnel. Now this funnel, the funnel is used to direct the rainwater into the cylinder that is collecting the water. So it is done so that the funnel directs the water that is being collected from the rain, and the water is collected into the collecting cylinder or the measuring cylinder. Now this funnel should not be too wide, and it should also not be too narrow. So when it's too wide or too narrow, then the recordings that will be collected from the rainfall will be different, and they will not be accurate. So we need it not to be too narrow or too wide. The readings of the rain gauge, that is the amount of rainfall, should be done at the same time every day. When I talk about the same time every day, this is what I mean. Let me give a practical example. If you have a rain gauge in your school and then you try to record the amount of rainfall collected, you make sure you set a specific time that you're going to check the readings. So let's say, for example, you decide that you're going to check the readings in your rain gauge at break time. I'm sure your break comes between 10 to 10:30, somewhere there. So let's assume your break is at 10:30. So you say that you're going to check the readings of your rain gauge the same time every day. So if you decide that Monday you're checking it at 10:30, make sure Tuesday you check it at the same time. So if it is Monday 10:30, Tuesday will also be 10:30, Wednesday will also be 10:30, Thursday will also be 10:30, Friday will also be 10:30. So that's what I mean by it. The readings should be taken the same time every day. Don't take the readings today. You take the readings at 10:30, tomorrow at 11:30, the next day at 8. That is wrong. There is aspect of evaporation, so you have to have the same time in order to get accurate results. As you go on recording the amount of rainfall, there are days that you'll find there is no amount of rainfall collected. There was no rain that day. So for that reason, either very little amount was found or no amount at all. So when such happens, when there is too little rain, such that the recordings are too small, you record trace. You record trace. So if the rain is too little, you record trace, and that is the recording of the word trace there. And if there is no rain at all, then you record nil. So if there is too little, record trace, and it's written in capital. Whereas if there is no rain at all, then you record nil. Now we have these weather instruments. These weather instruments work on specific principles. So when we come to a rain gauge, it works on the principle that matter occupies space. So from our previous knowledge on matter, we understand that matter is anything that occupies space and has mass. So it works on the principle that matter occupies space. And the matter we are talking about here is liquid. And the liquid is the rainwater. The liquid is the rainwater. So matter occupies space, that is the principle. And the matter, specific matter we talk about here is liquid. And the liquid is the rainwater. So that is the principle at which this rain gauge works on. So matter occupies space, and this matter here is the liquid. So we can look at the diagram of a rain gauge. So the diagram of a rain gauge coming there shortly. So as my technical people are trying to sort me out, so that we can be able to see the diagram of a rain gauge, we can look at the next weather instrument. And as I said, we'll be specific on the weather instruments that we are going to talk about. So the next one we are looking at is a wind vane. And it comes from the word wind. When you talk about a wind vane, we have the word wind, so it must measure an aspect of wind. So a wind vane, in this case, it measures the direction of wind. So a wind vane measures the direction of wind. That's what it measures. Now, a wind vane has an arrow and it has a tail. So we have an arrow and we have a tail. I'll be showing you the diagrams shortly. Just be patient. So the arrow, yes, okay. Welcome back. We are continuing from where we had stopped. Sorry for that. So we were to look at the diagram of a rain gauge. So that's the diagram of a rain gauge, as you can see. So we have the upper part, that is 30 centimeters. Then we also have the lower part of the rain gauge that is dug into the ground. So we have the ground level. So this is the ground level. So we have 30 centimeters that is above, and we have 15 centimeters that is dug into the ground, and we said it is left so that it can prevent splashing of water. So it is dug into the ground for two reasons, and the main reason is to reduce the rate of evaporation. And apart from reducing the rate of evaporation, it is also dug to make it firm. So reducing the rate of evaporation, that is the main, and then making it firm is also another use. So we have the collecting cylinder, which is calibrated in millimeters, because those are the units for measuring amount of rainfall. So this is the funnel I was talking about. So we have the funnel there. The funnel, as I had said earlier, it should not be too wide, neither should it be too narrow. It should fit exactly inside. So that is about a rain gauge. So we can also look at a wind vane. And I'd said earlier that a wind vane is used to show direction of wind. And a wind vane has what we call a head and a tail. So the head is also called an arrow. Then the tail is just called the tail. Now when this wind vane is being constructed, it is constructed in such a way that the tail should be twice larger than the head. I repeat that, the tail should be twice larger than the head. So it should be twice larger than the head, such that the arrow can point where the wind is blowing from, and the tail can point where the wind is blowing to. And the other reason is to also enable it to rotate while the wind is blowing. Remember, wind can change direction. Wind can blow from east to west. It can blow from north to south. So it can blow from any direction. So the tail should be twice larger than the head to allow the head to show where the wind is blowing from, and that's the head to show where the wind is blowing from, and the tail to show where the wind is blowing to. So we can look at a wind vane. So it also has a compass, and the purpose of a compass is used to show direction. And the tail, as I had said, the tail here is twice larger than the head. The arrow points where the wind is blowing from, and the tail points where the wind is blowing to. It is also placed in an open field where there is no obstruction. And then, just as a rain gauge, a wind vane also acts on a principle. And a wind vane acts on the principle of air in motion. So it works on the principle of air in motion. Remember, from your previous knowledge, we say moving air is called wind. Moving air is called wind. So a wind vane will work on the principle of air in motion. Then, to allow free rotation, if it is a constructed wind vane at your school, we can use a biro casing. So the biro casing can act as a pivot to enable free rotation, because the wind vane has to rotate depending on the direction of the wind. So wind has no specific direction where it blows from or where it blows to. So for that reason, because it keeps on changing, the wind vane should be able to rotate. When the wind points this direction, then the arrow of the wind vane will point that direction. When the wind blows from this direction, then the arrow should also point that direction. So that is about a wind vane. And we can have a look at the diagram of a wind vane. So we have a wind vane, which is there. So this is what we call the arrow. You can also have it called the head. So this is what we call the tail. And this is the compass. So it has the compass. So you can be asked, what is the function of the compass in a wind vane? The function of a compass in a wind vane is to show direction. So when you look at that wind vane, you can see the wind vane has the 4 cardinal points. That is the north, the south, east, and west. So that is a wind vane, the diagram of a wind vane. You can find an examiner who asks you a practical question. So I'm going to ask you the practical question. Mary was walking to school one morning and she realized her shadow was on the right side. What was the direction of the school from the home? I repeat the question. Mary was walking to school one morning and she realized her shadow was on the right side. What was the direction of the school from home? So when you are given such a question, so you can have your compass drawn here. So this one is the north, this is south, this is east, and this is west. Now there are specific things in the question that you need to focus on. Number one, Mary was walking to school one morning. So what comes to your mind if it's in the morning is about the sun. And we know the sun rises in the east and sets in the west. So if it was in the morning, the sun was on the eastern side. So she was walking to school and her shadow was on the right side. The shadow is usually the opposite direction of the sun. So if the sun is to the eastern side, then the shadow is on the western side. So we assume the shadow is towards this side. So that is the shadow is towards this side. So the shadow is on the right side. So it means while this person was walking, this Mary, this was the right and this was the left. So it means the home is opposite the school. So the home is either north or south, likewise to the school. Now you come back to your question. While Mary was walking to school one morning and she realized her shadow was on the right side, what was the direction of the school from home? So she was coming from home to school. She was coming from home. So home will be this side because she's going to school. And then this side will be school. Such that the shadow should be on the right side. So this is school. So we have school towards the northern side. Now you answer your question. The question is, what was the direction of the school from home? What was the direction of school from home? So this person was walking from south to north. So the direction of school from home, you go where we have home, and the direction is towards the northern part. So that is how best you can answer such a question. So we can also look at the next weather instrument, which is a windsock. And from the word sock, so it has something that looks like a sock. Now, it is made up from a very strong material, which can also be polythene if it's an improvised diagram. And this material is to withstand the strength of the wind. So a windsock measures two aspects of wind, but there is the main aspect in which it measures. So a windsock mainly measures strength of wind, but apart from measuring strength of wind, it can also be used to measure direction of wind. So those are the two aspects that a windsock measures. So it measures the strength and direction of the wind. A windsock is mostly found in airports and airstrips, which gives the pilot direction that he or she is likely to use during landing. So we have a windsock which measures two aspects. So the first one is strength of wind and also direction of wind. A windsock is also painted. A windsock is also painted white and black, and it's painted white and black for the purpose of visibility. For the purpose of visibility, in case you're wondering what is visibility, in order to be clearly seen. That's what we mean by visibility. So it is painted black and white. Now I said it's found in airports or airstrips. So the pilot looking at a windsock should be able to see it clearly. That's why it's painted white and black. Or if not white and black, we can also have contrasting colors which can enable visibility. So we have, in a windsock, we have the mouth of the windsock and we have the tail of the windsock. The mouth of the windsock is where the wind gets in, and the tail of the windsock is where the wind gets out. So the mouth of the windsock should be wider than the tail of a windsock. So the reason is it should be wider so that when the air gets into the sock, it should have enough time before it passes. If the tail and the head were of the same width, then air could just pass and the windsock could not be able to pop up. So we have the opening where the wind gets in should be wider, and where it leaves it should be narrow, so that it can be able to pop up. And while it's popping up, we can be able to determine the strength of the wind. As other weather instruments, a windsock also works on a principle, and it works on the principle of matter occupies space. It works on the principle of matter occupies space, and the matter that I'm talking about here is the wind, which is moving air. Just as a rain gauge and a wind vane, a windsock should also be placed in an open field free from obstruction. So the wind should not be obstructed in any way. So you don't need to put it where we have tall buildings or where we have trees. So we have a diagram of a windsock. So those are the points to note if you are taking notes. So those are the points to note. So this is the mouth of the windsock. So this is the mouth of the windsock, and this is the tail of the windsock. So from my diagram, as you can see, the mouth is wider than the tail. So this material should be a very strong material. Should be a very strong material. Should be a very strong material. Then when the wind is blowing, it's able to pop up. Now this is what I refer to as popping up. So with here we can be able to determine the strength of the wind. Now looking at our second diagram, so we have diagram A and we have diagram B. We can use diagram B to show the direction of the wind. Now, where the tail of the windsock points, it shows the direction where the wind is blowing to. So in this case, the wind is blowing from this direction. So from this direction. So if this is west and this is east, we can say that the wind was blowing from west to east. That is how a windsock can be used to show direction. So we can move on to our next weather instrument and our final weather instrument. So we have looked at 3 already. So we are looking at the last, which is a thermometer. And a thermometer is an instrument used to measure temperature. temperature is measured in what you call degrees Celsius. Those are the units for measuring temperature. Now, according to our syllabus, we are going to look at two types of thermometer. We are going to look at an air thermometer and a liquid thermometer. So we can start with the first type of thermometer, which we call an air thermometer. Now, the diagram of an air thermometer, it has a thin-walled glass at the top, then a narrow tube, then we have a collecting, or we have a cylinder that has water. So for accuracy, we use colored water. Now, an air thermometer works on the principle of expansion and contraction of matter. Expansion and contraction of matter. The matter we are talking about here is air. So when the temperatures are high, the air gets heated. And we know matter expands when heated and contracts when cooled. So when the temperatures are high, the air gets heated and it moves downwards. So let's look at the diagram as I talk about it. Let's look at the diagram of an air thermometer. So this is the diagram of an air thermometer. So I'll explain as you look at it. So we have a bottle, and the best material for making this bottle should be thin-walled glass bottle, such that expansion and contraction of air can easily be noticed. So we have an airtight cork to prevent air from getting. Remember, what is inside here is air. So we also have a narrow tube. The tube should be narrow. Why should the tube be narrow? It should be narrow so that it can be able to record even the slightest changes. Then we have the scale. We have the scale of an air thermometer. And the scale of an air thermometer runs from up to down. The scale of an air thermometer runs from up to down. So you can have your readings here as your 1, as your 2, 3, 4, and 5. We also have a rubber band or a thread just to hold it in position. Then we have colored water. Colored water is used for the purposes of visibility. Then we have a stand. Now, an air thermometer works on the principle of expansion and contraction of air. When the temperatures are high, air inside the glass bottle gets heated. Since matter expands when heated, the air will expand, and while it expands, it pushes the colored water downwards. So we have colored water here. So while the air is expanding, it pushes the colored water downwards, and as colored water goes downwards, we have a higher reading on the scale. So we look at the expansion and contraction of air. So when the temperatures are high, air in the thin-walled glass bottle gets heated and moves downwards. So as it moves downwards, it pushes the colored water downwards also, therefore having a higher reading on the scale. But the opposite also the same. When the temperatures are too low, the air inside the glass bottle gets cooled. So because it gets cooled, it contracts. As it contracts, the air gets pushed upwards. So as the air gets pushed upwards, then we have a lower reading on the scale. Remember, the scale runs from up to down. So we can have a look at the diagram. Now there are specific things or specific questions that you need to look at. We use a thin-walled glass bottle to record even the slightest changes. We use a narrow tube also to record slight changes. The scale must run from up to down, and we use colored water for visibility. So those are the points that you need to note about an air thermometer. We also have a liquid thermometer. If air thermometer works on the principle of expansion and contraction of air, then a liquid thermometer works on the principle of expansion and contraction of the liquid, such that when the temperatures are high, the liquid gets heated and it goes up. As it goes up, it records a higher reading on the scale. So the scale in a liquid thermometer is opposite to the scale of an air thermometer. So the scale in a liquid thermometer runs from down to up. That's the first difference you need to note. And then a liquid thermometer does not have an airtight bottle because we don't check the expansion and contraction of air. We check the expansion and contraction of liquid. So it also works on the principle of expansion and contraction of matter. But the matter here now is not air as in air thermometer, but liquid. So we can have a look at the diagram showing a liquid thermometer. So those are the points: expansion and contraction of liquids. Scale runs from down to up. It has a narrow tube, and we use colored water. So this is the scale. So this is our scale, and our scale runs from down to up. So you can have 0, you can have 5, you can have 10, you can have 15, you can have 20, in that order. So this one is also a narrow tube for the same reason, to record the slightest changes. This one is colored water. Colored water is used for visibility. Colored water is used for visibility. So this is the bottle that we are going to use. So the bottle should also be able to record the slightest changes in temperature. Now this works on the principle that matter expands when heated. So when the temperatures are high, the water in the bottle, the colored water in the bottle, gets heated. As it gets heated, it expands because matter expands when heated. As it expands, it moves upwards. So with increase in temperature, the colored water keeps rising. As it keeps on rising, we'll get a higher reading on the scale. So as temperature rises, we get a higher reading on the scale. The opposite is also the same. When the temperatures are too low, now the water in the bottle will contract and it will start to move down. So when the temperatures are low, it moves down, and we'll also have a lower reading on the scale. So that is about a liquid thermometer. Now, just a quick recap. We have talked about 4 weather instruments. We have talked about a rain gauge used to measure amount of rainfall in millimeters. We have talked about a wind vane used to show the direction of wind, and the arrow points where the wind is blowing from, and the tail points where the wind is blowing to. We have looked at a windsock, which measures 2 aspects, that is strength and direction of wind, but mainly the strength. We have also looked at thermometer, which we have 2 types of thermometer, a liquid thermometer and an air thermometer. They both measure temperature. Now we look at the differences between an air thermometer and a liquid thermometer. An air thermometer has a glass bottle, while a liquid thermometer does not have. That is the first difference. The second difference, an air thermometer works on the principle of expansion and contraction of air, while a liquid thermometer works on the principle of expansion and contraction of the liquid. The scale in an air thermometer runs from up to down, while the scale of a liquid thermometer runs from down to up. The airtight cork in an air thermometer is found at the top, where we have an airtight bottle, whereas the airtight cork in a liquid thermometer is found at the bottom, where we have the bottle with the colored water. So those are the differences between an air thermometer and a liquid thermometer. Having looked at that, we can look at some few questions that were set in KCPE, and as per now, you can start asking questions if you have. There is a number right there on your screen. You can send your questions. I'll be able to respond to as many as I can. So we look at some of the questions that were set in the KCPE examination. So we have 2018 as our first question. The diagram below represents a certain weather instrument. The instrument can be used to show. The first thing that you do, you're going to read the answers and the questions so that you understand. So we have this is a windsock, first of all you identify what type of weather instrument it is. It's a windsock. So having identified it's a windsock, you can now answer your question. So we have direction of wind only. This one you can say it is a wind vane. Speed and direction of wind, we don't measure speed of wind using a windsock, so that is wrong. Speed only, we don't measure speed using a wind vane. So the right answer is direction and strength of wind. Another question, number 2015, number 30. The following materials can be used to construct a certain weather instrument: small plastic bottle, large plastic bottle, manila paper, sellotape. The weather instrument likely to be constructed is, so we have things that we first of all eliminate some weather instruments based on the materials that we have. We have small plastic and large plastic. We don't need plastic when we are making a wind vane, so we remove a wind vane. We also don't talk about an air thermometer. Sorry for that. So we remove a wind vane because we don't need plastic bottles. Now we have an air thermometer and a liquid thermometer. When you talk about an air thermometer and a liquid thermometer, we need to have some colored water somewhere, so we take it out, and our right answer is rain gauge. Our right answer is supposed to be rain gauge in this case. Now, when we talk about materials for making weather instruments, there are specific things that you look at. So when we talk about colored water, remember we're talking about either air thermometer or liquid thermometer. When you talk about an airtight bottle, now that becomes an air thermometer. When you talk about two containers and a scale, that should be a rain gauge. When you talk about making of an arrow, that should be a wind vane. And a windsock, you talk about a strong polythene. So those are few points that you can use to differentiate. 2014, number 28. Pupils constructed a weather instrument with an inner tube. So this is our last question. The mistake made in the construction was. Now we look at colored water. Colored water cannot be a mistake. So this is a plus. Placement of the scale. We come and look at the scale. This is a liquid thermometer, and we said a liquid thermometer the scale should run from down to up. So when we look at our scale, it runs from up to down. So that is a mistake. We have looked at it. We look at using an arrow tube. That is a correct step. Then you closing the cork tightly. You look at the cork. The cork is down there, which is correct. So that is another question that was used or that was given in 2014. So there are several questions that you can look at them. Due to time factor, we might not look at all of them, but I've just sampled two, and there are so many questions on the same. You can check with KCP Made Familiar and familiarize yourself with such questions. So in around 2 minutes, I'm going to answer some of your questions, if there are any that have been sent. I'm looking at the questions. I am Aileen. What is principle does a wind vane use? A wind vane works on the principle of air in motion. A wind vane acts on the principle of air in motion, and moving air is called wind. Elaine, I hope your question is answered. I'm Felix Ouma from Eldoret. What is the function of the funnel in a rain gauge? The function of the funnel in a rain gauge is to collect the rainwater into the measuring cylinder. Let me take you back to the diagram of a rain gauge. This, Felix, so that you can be able to understand. So Felix and the others, you can have a look at our rain gauge. You can look at our rain gauge. So Felix, let me just explain to you. So we have a funnel, and this funnel collects the rainwater because rainwater falls as drops. So it collects these drops and put it in the measuring cylinder. Remember, this water can still be taken to another measuring cylinder. So that is the function of a funnel. Let me look at any other question. I am Procy. Procy, kindly tell me the main differences between air thermometer and a liquid thermometer. Procy, the differences between an air thermometer and a liquid thermometer, I will repeat. So an air thermometer has an airtight bottle at the top, while a liquid thermometer does not have. That is the first difference. The second difference, an air thermometer works on the principle of expansion and contraction of air, while a liquid thermometer works on the principle of expansion and contraction of liquid. Difference number 3. An air thermometer, the scale runs from up to down, because as the air expands, it pushes the liquid downwards, therefore recording a higher reading on the scale. Whereas a liquid thermometer, the scale runs from down to up, such that as the liquid, remember the liquid is at the bottom, when the liquid gets heated, it expands. As it moves upwards, it records a higher reading. So the difference is also on the scale. Air thermometer from up to down, while a liquid thermometer, the scale runs from down to up. Those are the differences between an air thermometer and a liquid thermometer. Okay, someone is asking a question, the last question here that I can see. A thermometer is used for. Now, as I started, I said I'll be very specific because of the syllabus. And I talked about 4 weather instruments, but those are not all the weather instruments. Because you have asked, let me mention, we have a thermometer, which has cups that face the same direction, and it is used to measure the speed of wind. A thermometer measures the speed of wind. Apart from a thermometer, we also have hygrometer. And hygrometer uses the human hair. And hygrometer measures humidity. It determines the level of humidity. We also have a sunshine recorder. Sunshine recorder is used to measure the intensity of sunshine. And then we have the last, which is a barometer. And a barometer is used to measure air pressure. But remember, these weather instruments are not examinable as such, because in your syllabus you don't talk about them. So having answered all your questions, I would like to end my lesson there. Stay safe, keep safe till we meet again. Have a good day. Beats Production.